The chemical reaction that causes addition-curing silicone formulations to vulcanize is known as platinum-catalyzed hydrosilylation. The following process occurs again and again. When a vinyl functional polysiloxane and a hydrogen functional polysiloxane, the crosslinker, come together in the presence of a specialty platinum catalyst, the catalyst joins the two molecules. The platinum transfers the hydrogen to the vinyl group, simultaneously producing a new silicon-carbon bond. The process is irreversible, and since the platinum is not consumed, it can in principle repeat the reaction any number of times. As cross-linking progresses, there is initially an increase in the mean length or mass of the siloxane chains, and hence in the viscosity of the silicone, until the silicone ultimately becomes a solid elastomer. However, certain substances, such as heavy metals or compounds that contain sulfur or nitrogen, are capable of bonding to the platinum and of sometimes completely inhibiting its catalytic action. These substances are consequently known as catalyst poisons or inhibitors. Here the inhibitor is represented by the small yellow spheres. As can be seen, platinum can no longer form any bonds. The silicone does not cross-link, the compound remains liquid.